All right, question number 16. Which expression is equivalent to this polynomial that we have here? All we're doing is just adding. I'm going to add like terms. So notice I have r squared and 6r squared. Those are like terms. That's -1 minus 6. That gives me -7r squared. I can eliminate two of my answer choices right now. I can eliminate G and I can eliminate J. Okay, that tells me, looking at the next one, the difference between the next one is the next term. That means I might be able to eliminate my answer choice really quickly with the next term. I'm going to look at 5r and 7r. That's 7 plus 5, which gives me 12. That becomes plus 12r. That is this answer here, so that eliminates F, and I'm done. Simple, easy. We can go ahead and finish just to double check. 10 minus 18, that gives me -8. For these two like terms right there, we're good to go. Number 17, which graph represents the solution of this? So here I have a y-intercept of -4. I'm going to see if I can eliminate any of my answer choices from that. Nope, they all have a y-intercept of -4. My inequality symbol doesn't have a bar underneath, so that means my line should be dotted. So that's going to eliminate A, and that's going to eliminate B. So now looking at C and D. D has the coordinate point 0, 0 as a solution. C has 0, 0 not. So I'm going to plug in the point 0 in for Y, and I'm going to plug it in for X. Is 0 greater than -4? This is a yes. So that means it should be a solution. So I'm going to shade the side that contains all of the solutions to my graph, which gives me my answer choice, D. Number 18, the bank account earning annual compound interest is open and no additional deposits or withdrawals are made after the initial deposit. The balance in the account after X years can be modeled by this function. It's an exponential function. Reminder, your exponential function is y is equal to a times r to the power of x, okay? Your a represents the initial value. So this 850 tells me that I have an initial balance of 850, okay? 1.025, that is a value. If I add those together, that means that my value is greater than 1. That means this is an increasing function. Whenever your r is greater than 1, then we have an increasing, we have a growth. F says account decreasing. That's gone. G says account increases at a rate of 2.5 per year. This might be a good answer. H says the initial balance of the account is 1,025. Nope, the initial balance of the account was 850. The balance in the account at the end of 1 year is 850. That's incorrect. That is our initial amount. By elimination, it has to be G. If I look at this, when I take 1.025 and I subtract 1 from it, that gives me 0.25. And if I want to convert that to decimal, that would become percentage, that would become 0.5%. So we are good to go on number 18. Number 19, we are going to have to use our handy dandy calculator because we have a table list of values. This is the number of months since 2011. And then this is the number of text messages. We want to know what is the best model that models the data given to us in this function. So in order to do that, I'm going to use my handy dandy calculator. I got to pull it up. All right. The way that I'm going to do this is I'm going to click this button. I got to scroll up. Give me 1 second. Okay. I'm going to click this button that says Step. I'm going to click this where it says Edit, and I'm going to hit Edit. I have L1 and L2. In L1, I'm going to enter all of the data that I have in the first one. So I have 10, I have 15, I have 20, I have 30. Oops, I missed 25. 25, I have 30, I have 35, I have 40. Then the next one, I have 3, I have 10, I have 17, 27, 44, oops, 44, 64, 86, 112. Make sure that these two columns match. They do. I'm going to go back to stat. I'm going to go over where it says calc, so I'm going to use my arrow button. Then, since we know this is a quadratic, I'm going to go to this line that says quad regression. I'm going to hit enter. I'm going to hit enter all the way down and hit enter. I'm going to match the A value with the A value on my answer key. So if I look at this on my answer key, A is out, C is out, okay? B and D both have the right A value. So now I want to look at the B value. My calculator worked out that's going to be negative 0.14, so that rounds up to 1.15. Then the C value matches 2.3 or 2.73. This matches 2.73, so that works out. Okay. It would have been this one if we didn't have if our C or if our B value was 0. That's the only way that you can handle that question on this. Technically, you could graph each one and then check your table, but that's the faster route than just going through and checking and graphing each one. Number 20, we were looking at this. We want to know what the rate of change. Remember, rate of change is your slope. I can either look at the graph. If I'm looking at the graph, if I notice this negative 3.6 is not a perfect point, so I'm not going to use this to graph it. I'm going to go ahead and use my points and use the slope formula. So I'm going to go ahead and I'm going to say m is equal to, I'm going to do 2 minus 3.6 over 5 minus becomes plus 3. Okay, 2, so I'm just going to use my calculator. I'm going to say 2 minus 3.6 gives me negative 1.6. We're going to divide that by 5 plus 3 gives me 8. So that becomes negative 0.2. So this is going to be m is equal to negative 0.2. Because when you talk about filling the bubbles in your graph, you'll get like 0, 1, 2, 3, and there'll be decimals in there and stuff like that. You'll probably just do, it'll probably be like negative, and then you'll put a point and then the number 2. You'll be a plus or negative. Since it's negative, you'll put minus, and then you'll put point, and then you'll put 2. Number 21, which graph best represents this function? The easiest way is just go ahead and graph it. So I'm going to go to y equals, I'm going to put negative x, I'm going to square it, plus, oops, that's 6x minus 1, and I'm going to graph it. It has it in my right quadrant, so it's either A or D. The difference between A and D is the vertex. So I'm going to go ahead and see if I can get the vertex. So second graph. The vertex, remember, I want to look for my symmetric pairs. Okay, I want to look for the pairs that start to match. If I notice here, I've got 7 here and 7 here. So if I were to use my arrows up, I've got 7 here and then 7 there. I got 4 there and 4 there. That means those are my symmetric pairs. That means my vertex is at 3, 8. So this one is 3, and that's 8. So A is my answer choice. D has a vertex at 3, 10. All right. And I'm going to go ahead and finish that one. And I will do the next video and the next question in the next video. I will see you later.